question number 3 on practice test 2. Again, I'm going to be a little quicker with these only because I've done practice test number 1, and a lot of these are similar type problems. So we want to know the acceleration from 7 to 10 seconds. I'm seeing a lot of people counting squares and guessing, and I really don't like that for the slope. So I'm just going to tell you right now on your real test, you're going to actually need to use the rise over run formula. I really want to see you start using that. So here I'm at 7,0 and going to 10,10. So let's go ahead and actually get the acceleration as the rise over the run. So that's going to be 10 minus 0 over 10 minus 7. That's 10 seconds minus 7 seconds. So we get 10 over 3. And so that's going to give me 3.3 meters per second squared. Now, is the object moving from 7 to 10 seconds? Yes, it is. Yes. And increasing speed. Now that might be a little bit more than you need to write, but it's good for us to note that at least in a practice test. Now it says here, what is the displacement of the object from 7 to 10, from 0 to 10 seconds? So let's be clear. We have this rectangle here. It's got a length, it's got a width of 3 and it's got a length of -4. And then we have this triangle part here, so that's 3 to 7, that's a base of 4 and a height of -4. And lastly, we have this triangle near the end. It's got a base of 3 and a height of 10. So let's go ahead and calculate all these displacements. So that's going to be 3 times 3 times -4. That's the rectangle part, plus, here's the upside down triangle part, 1/2 times 4 times -4 plus 1/2 times the base of 3 times the height of 10. And so that's going to give me, let me just make absolutely sure I got that right. So 1, 2, 3, 1, 2, 3, 4. Okay. And then 1, 2, 3, 4, 1, 2, 3, 4. And then here, 1, 2, 3, and height of 10. Okay, good. So when we actually calculate all this out, that's going to be -12 minus 8 plus 15, and that's going to give me a displacement of -3 centimeters. Now, does the object ever come to rest? Yes, it does. At 7 seconds, v equals 0. Does the object ever change its direction? Yes. Again, at 7 seconds, it goes from backwards to forwards. And the reason you can tell that is if you look at this graph, all of this is negative backwards motion. It is going backwards, but it's slowing down. It stops, and then it starts moving forward and speeding up. Is it possible to determine the initial position from the graph? No, never from a velocity graph. All right, so that's problem number 3. We'll take a look at problem number 4 in the next set of videos.